So today we'll continue with conductance in electrolytic solutions. And in today's presentation, we actually have to study conductance. To be more precise, have to study conductivity actually, but we won't go there directly. We'll take this route. We will first try to understand resistance क्या होता है. From resistance we'll gather what is conductance, how can we define conductance of a conductor, and then we'll move forward. So first things first, let's see resistance क्या होता है. As far as the literal meaning of the word is concerned, it means hindrance. Every conductor will have some resistance, will show some resistance to the flow of electricity. What is that resistance? How does this conductor show that resistance? It is all explained by a law known as Ohm's law. Now, according to this law, if to the ends of a conductor we apply a voltage E and current I flows through it, and then if we have to calculate resistance R, फिर इस conductor की resistance क्या होगी? That R, resistance of the conductor, will be equal to E by I. When I've taken a very simple diagram here, when will that happen? When you're applying voltage E and current I is flowing through this conductor, it will have some resistance, and the value of that resistance R will be equal to E by I. In terms of units, we already know that voltage is taken in volts and current is taken in amperes. Therefore, the ratio between that volts and amperes is equal to a quantity known as ohm. Since this is the Ohm's law, the quantity is known as ohm. This ohm is written, it is denoted by this symbol. It's a Greek symbol, I think. And if we have to decide for the units in SI system, ohm is equal to this whole entity. इतना सब कुछ ये कहाँ से आता है? Because when we convert into SI system, we take volts in work per unit charge, then work में we take force into consideration, and force में mass and acceleration आता है. सारी चीज़ें taking all of those things into consideration. This is the unit of resistance in SI system. So resistance of a conductor R is equal to E by I. Now if we know the resistance of the conductor, we can very easily find out what is the conductance of that conductor, because the two are inversely proportional to each other. As is written here, reciprocal of resistance is conductance, or reciprocal of conductance is resistance, one and the same thing. We represent conductance by G, therefore this G, conductance, is equal to 1 by R, so that if we know R, we can calculate G. If we know G, we can calculate R. And units भी बहुत easy देखना है अब conductance के, since we know the units of R. If R is ohm, conductance G is per ohm, ohm minus 1. Inverse में अगर इस चीज़ को पढ़ा जाए, it is mho. Or another unit is Siemens, and 1s is equal to 1 inverse ohm. So in this case, we have the very basic concept of resistance and conductance, and the two are inversely proportional to each other. Reciprocal relationship है इनका, which is very easy to understand. अगर आपसे कहा जाए कि कंडक्टर है और इसकी resistance जो है 10 ohms है, what is its conductance? Conductance will be 1 by 10 mho, mhos, या 1 by 10 inverse of ohm, right? या अगर resistance conductance बताई जाती है, resistance उसका inverse होगा. Now that we know what is resistance and what is conductance, we can talk about conductivity. आपके syllabus में आपको specific conductivity पढ़नी है, आपको molar conductivity पढ़नी है, equivalent conductivity भी होती है. These are the ways of expressing conductivity under various circumstances, under various situations. And equivalent conductivity, I think, is not in your syllabus. We shall see. So the first type we'll be doing is specific conductivity. We'll take the same route. We won't go directly to defining specific conductivity. We'll again start with resistance. Now it has been studied that resistance of a conductor जो है, it is 1 directly proportional to its length. For example, अगर हमने ये conductor लिया हुआ है, it has been seen that the resistance shown by a conductor is directly proportional to its length, and it is inversely proportional to its area of cross section A. So that in the form of an equation we can write capital R, which is resistance, is proportional to L divided by A, or R is equal to rho. This symbol is read as rho L by A. Let's call this equation equation 1. Now what is this rho? It's a constant. We speak so much about constants, and I say this again and again. It is very easy, very important to understand these constants and remember their definitions, their specifications. Now this rho in this case is a constant of proportionality, and it is called specific resistance or resistivity. Recommended nomenclature is resistivity. That is why मैंने resistivity ही highlight किया है, यहाँ पे bold में लिखा है. This rho is a constant and is known as resistivity, and its value depends upon the material of the conductor. Right? Whichever material you take, that determines the value of this constant. Now if in this equation L is 1 centimeter, length of the conductor is 1 centimeter, and A is 1 square centimeter, then we can say R is equal to rho. And if we have to define this rho, this constant of proportionality, which is known as resistivity, how do you define it? Resistivity is the resistance. Rho is equal to R. But when the conductor has length equal to 1 centimeter and area of cross section is 1 square centimeter, we're therefore talking about a cube. Thus, in very simple terms, we can say resistivity is the resistance of 1 cubic centimeter of the conductor. Right? Now what have we done here? We have decided to define resistivity before conductivity. From resistance we know what resistivity is, and as you already know that conductance G is a reciprocal of R. Conductance G is a reciprocal of resistance R. Similarly, conductivity जो हमें पढ़ना है यहाँ पे, it is the reciprocal of resistivity. So now that we know what resistivity of the conductor is, we can find out its conductivity, because reciprocal of that resistivity is conductivity or specific conductance. Again, out of the two names, conductivity is the recommended nomenclature by IUPAC, and it is denoted by kappa, this symbol, K-like symbol. It is again, I think, a Greek symbol, and it is read as kappa. Now G is the conductance of the solution and kappa is the conductivity. Till this point what we have learnt is R is the resistance and rho is the resistivity. G is the conductance of the solution and kappa is its conductivity. So that this is how we move ahead. Now we know that R is equal to 1 by G, reverse reciprocal relationship hai. Therefore rho is equal to 1 by kappa. Resistance and conductance are related to each other like this. Resistivity and kappa are related to each other like this. Now we'll substitute these values in equation 1. In this equation, we take this equation again, which was R is equal to rho L by A. Substituting the value of R and substituting the value of rho, what do we get? In place of R, we substitute 1 by G. In place of rho, we substitute 1 by kappa multiplied by L by A, or we can say kappa conductivity is equal to G conductance into L by A. Now if L is 1 centimeter and A is 1 square centimeter, then this K kappa is equal to G. Conductivity is equal to conductance when L is 1 centimeter and A is 1 square centimeter. So that now we have to define, जो हमें असली पढ़ना है, specific conductivity or conductivity simply. We now are able to define that. Conductivity of a solution is therefore defined as the conductance of a solution. But when conductance of a solution of 1 centimeter length and having the area of cross section as 1 square centimeter. These are the specific values, then only kappa conductivity is equal to G conductance. Alternatively, you can define this as taking all the three dimensions, length, breadth and height. We can say in simple terms, conductivity is the conductance of 1 cubic centimeter of the solution of the electrolyte, right? Now here we have the definition. Additionally, if the volume of the solution is V cubic centimeter, we write it as conductivity at dilution V is written as kappa V, and at concentration C it is written as kappa C. Now units, very simple, we know that kappa is in reciprocal relationship with rho, resistivity. If we know the units of resistivity, rho is equal to R A by L, and this rho comes out to be ohm centimeter, or the symbol of ohm centimeter, or ohm meter. In SI system we'll use ohm meter. Since this conductivity kappa is 1 by rho, we already know the units of rho, we can find out the units of kappa. Ohm inverse, centimeter inverse, ohm inverse, centimeter inverse, or in SI system it is ohm inverse, meter inverse, or we can say Siemens inverse centimeter, and this unit also in SI system can be written as Siemens meter inverse, right? Don't lose track, ये सब कुछ हम पढ़ रहे हैं इसलिए because हमें specific conductivity पढ़ना है, and in this slide we have been able to define this conductivity here. It has a very important addition to it, variation of conductivity with concentration. जब भी आप conductivity पढ़ेंगे, चाहे आप specific पढ़े, equivalent पढ़ेंगे, molar पढ़े, you will have to describe, explain that how this conductivity varies with concentration. In this case, we are talking about specific conductivity, or which is simply called as conductivity. Very, very important to remember that specific conductivity of a solution, of an electrolytic solution, decreases with dilution. Right? We are doing conductance in electrolytic solutions. If you dilute that solution further, what will be the effect on its specific conductivity? It will decrease. How? Because on dilution, number of ions will increase. So number of ions जब increase हो, it should have increased the conductance. ज़्यादा ions होंगे, ज़्यादा moment of ions होंगी, conductivity बढ़नी चाहिए. But this is specific conductivity. We are speaking about a specific area. Per centimeter cube हमें देखना है. जब हम dilution करेंगे, overall number of ions will increase, but in that specific area per centimeter cube में number of ions present will be less. The reason is that on dilution, more ions are produced, which should lead to increase in conductance, but specific conductivity falls with dilution because ions present per centimeter cube of the solution become less. Right? That is why it is specific. We are considering specific dimensions, and within those specific dimensions only we define this conductivity. That is why it is known as specific or simply conductivity. ये चीज़ मैंने highlight की है because usually conductivity increases with dilution. In this case, in case of specific conductivity, it will decrease. So note it down.